Welcome back. In this lecture, we will discuss algorithm to user bias. Here's our lesson objective. Okay, so looking back at our paradigm where we talk about the different sources of bias and how they affect other components, we have the data that could be biased and affect the algorithm that processes that data. And then we have the next step, which is the algorithm itself could induce bias, and that can affect the user. And this is what we will talk about in this lecture. And this is called algorithm to user bias. And this is simply bias in an algorithm that may influence a user's behavior. So the first type of algorithm to user bias is called algorithmic bias. And this occurs that even if there's no bias in the data itself, that the algorithm, the machine learning model, is somehow going to induce a bias. And how can that happen? Well, especially when you consider something like supervised or reinforcement learning, these are things that could end up being part of the model. When you're looking at unsupervised methods, the bias could be present in the resulting analysis, like the clusters or the rules. And so some ways that this could happen is by engineering decisions that you may make. So if you're looking at a supervised model or a reinforcement-based model, the way you design that optimization function could potentially induce a bias. Same thing goes for a regularization strategy. The selection of target class, or with rule mining, your target items can also induce additional bias. So these are kind of the things to watch out for as you think through designing these systems. Will these decisions lead to skewed results one way or the other? But this has to do with the algorithms themselves and the models and the initial output of where they come from. So the next type of algorithm to user bias is user interaction bias. And this deals with how the user interacts with the interface and how they manipulate the resulting output. So there's two types of user interaction bias to consider. One is called presentation bias, and this results from how the information is presented in the user interface. And it's really easy with, say, a graph of data to skew information by manipulating the scales of the axes, for example. Ranking bias is another type of user interaction bias, and this happens with a lot of ranking algorithms where most popular results are put up front first, and as more people get interested in those results, they gain even more and more popularity. So this ranking bias ends up causing results to be self-referential. So popularity bias deals with more popular items ending up being exposed more. Now, this is similar to ranking bias, with the exception that there's another caveat where it's not necessarily going to be the result of human behavior. Things like social bots, fake reviews, and other forms of manipulation can bump up popularity, and this not necessarily is a result of user interaction. Emergent bias. This occurs with systems that are running for a long period of time and interacting with a population that itself may change. And it's also user-centric, and it happens when there are cultural changes within the population that interact with the output of the software. And finally, evaluation bias, and this one is particularly important. We talk about algorithmic bias, which mainly deals with kind of the training phase and how the model is produced. Evaluation deals with how you evaluate the model and make decisions like what hyperparameters to use and stuff like that. And so this deals with your evaluation criteria, and this has come up some measurements used to evaluate facial recognition software, were found to be biased towards certain racial and ethnic groups. So that's part of the reason this started to become very important. But there's many ways that evaluation bias can occur during validation and testing, and it could depend on the selection of the target class. I mean, one thing that's really important is how is ground truth and the target class actually defined for a given set of data. And in certain cases, that's very straightforward. In others, how those measurements are defined and created needs some engineering work, and you may wind up creating something that has an inherent bias in it. Notice that the selection of the objective function for which a model is optimized during training, that's on the algorithmic bias side. With evaluation bias, we're talking about the evaluation metrics, so this is more dealing with things like validation and testing. Anyway, this concludes the lecture. Stay tuned for more content.